Hi, everybody. Welcome back to Are We on the Same Page? I'm your host, Dave Thomas Rocker, and today I'm going to do my last video in my series on the history of invention. Today I'm going to talk about the inventions of the modern era that I'm defining as being between 1900 and 2024. I started making this series the end of last year, so I'm not going to through 2025. In any case, we're still in January, so not too much has happened yet this year. But let's begin. So before I begin, as usual, I'm going to do my usual pitch for my book called My Spiritual Journey, which is available both for Kindle and for paperback on Amazon. You can just search my pen name Dave Thomas Rocker because there's a lot of books called My Spiritual Journey. But anyway, I think you guys will enjoy it if you decide to buy it. It's $30 for paperback and $9 for Kindle. Anyway, that's a pitch for my book. Now let's begin the video for today. Um, so as usual, I've divided history into six eras. Starting with a prehistoric. I've done videos on five of these already. I'm on the last one now. And just to give you an idea of these eras, I mean, you guys can go back and watch the previous videos I've made if you haven't already. But I started 5 weeks ago, I guess, with the Stone Age, and that was defining between 5 million BC and 10,000 BC. And then after that, we had the ancient times for civilizations, and I'm defining that as being between 10,000 BC and 500 AD. Then I did, my 10, what I consider the 10 greatest inventions of the Middle Ages. I only did 10 for that era as well as the Stone Age, but I've done 20 for every other era. And I define the Middle Ages as between 500 and 1500 AD. Keep in mind that these years aren't set in stone. I just define them this way mostly to kind of use round numbers to make it a little easier. I know that there's more conventional definitions of when these eras have begun and ended, but I don't want to make too much of a fuss about that. After that, we had the Renaissance, which I defined between 1500 and 1749. After that, that was the last video I did so far. I did this one last week. This was on the Industrial Revolution, which I defined as being between 1750 and 1899. And today I'm going to do my final installment of the History Inventions. I'm going to talk about what I consider the 20 greatest inventions of the modern era, which I'm defining as being between 1900 and 2024. So anyway, without further ado, let's just get started with the history of modern inventions. So the invention I put, and there were a lot of really great inventions. I'm sure you guys know, during the modern era, there's a lot of modern inventions that we all enjoy, or can be you know put off by, or even some that may be dangerous. But and it's hard. It was kind of hard for me to weed it down to just 20 because I'm sure I left out several good ones. But anyway, this is my 20. So let's begin with that. Number 20, the photocopier. Um, this was, I think most of you, if not all of you, I'm sure, are familiar with photocopiers. They're used in just about every office. Every company that has an office where you have to print stuff has a copier. And nowadays, a lot of people have their own copiers and scanners, that they use with their PCs. So we can't deny the importance of the photocopier. And the guy who invented the photocopier was Chester Carlson in 1938. And he founded a new company, or he helped found a new company called Xerox. Actually, I think it was Joseph C. Wilson who capitalized on his invention. It was originally called xerography, by the way, and now we just call it photocopying. But the idea is you're really just taking a photograph of the thing you're copying, and it works electronically. So does an electronic scan. I'm sure you guys are all familiar with the process. I'm not familiar with the physics behind this that well, so I'm not going to try to explain how it works. But we all know the importance of photocopying because I think most of us have made photocopies of printed material, mostly maybe our butts too, as an office joke or whatever. I mean, you can pretty much photocopy whatever you want, you know. But the main practical uses for documents, printed documents. Anyway, that's the photocopier. Number 19, GPS. Maybe I should have put this one higher. I'm not sure. But GPS stands for the Global Position System. And this was developed, I believe, by the U.S. government, U.S. Department of Defense. Yeah. And it was, they started working on this as early as 1973. I guess it took them 20 years to complete it. It wasn't completed till 1993. But I think most of you have probably used GPS, navigating. I mean, it was a revolutionary invention. I mean, this invention is really remarkable in terms of the technology involved. And it involves 24 satellites. So there's 24 GPS satellites all orbiting the Earth. I think they have a 12-hour orbital period. And what happens is you have a handheld device. Nowadays you can do it with cell phones. You just upload the app. The one I like the best is Google Maps, but everybody seems to have their favorite apps for doing GPS related navigating. So when you turn on your GPS unit, it locks on to 24 satellites, and they triangulate your position and your velocity. Pretty amazing. And the amount of data that goes into this is pretty staggering. And I know a little bit about the math involved. I did study math. I have a PhD in math and a master's degree in physics. So I understand the physics behind how GPS works. So maybe I'll just explain it. Like I said, there's these 24 satellites. You only really need four, I think, to lock on to your position. And it doesn't just need spatial data, it needs time data as well. And the reason it does is because of special and general relativity. Also, it has to know your velocity. But each of these satellites has a timestamp. It says what time it is, but according to Einstein's theory of relativity, time is relative. Time depends on how you're moving. For one thing, that's special relativity. It also depends on how high you are orbiting. That's general relativity. So it has to take both special and general relativity in account when it locates you, when it tracks you. It has to take the time dilation factor into account. Otherwise, it wouldn't work properly. And based on all the data received by these satellites by your unit is the receiver, the satellites in orbit are the transmitters. It knows exactly where you are very precisely these days. I guess it took a few years to get the precision down to where it is now. I think now it's so precise you can locate yourself within a few feet, of the unit. And it calculates all the data on exactly where you are and how fast you're moving and in what direction. And it also incorporates maps. I mean, Google Maps has a little map overlaid on it that shows you where not only where you are, but it shows you a map of the area where you're going. And you can use these, I think they're most convenient for driving, but you can also use them when you're walking or when you're taking public transportation or whatever you're doing. So it's really, really a remarkable device. Now nobody ever has to ask for directions anymore because of GPS. I think one unfortunate side effect GPS has had is it's made people forget how to use maps. Just like people forgot how to do arithmetic when pocket calculators came out. So I think it's still important to know how to use a map, even though we have GPS. But anyway, that's GPS. And number 18, the solar cell. I think this was a really great invention. I mean, now we have solar power, which is, one of the big renewables. It's one of the big renewable sources of energy. And I think we should have a lot more of these solar cells. I mean, uh, there are problems with them. I think the biggest problem is that they're still pretty expensive. They've gotten a lot cheaper though. But let me just explain first a little bit of the physics behind solar cells. The physics was actually known back in the late 19th century. It's the photoelectric effect. And this, I believe, was discovered by a very famous German physicist named Hertz. The same Hertz who discovered radio waves. And Einstein was the first person who correctly explained the physics behind the photoelectric effect, which involves photons. He hypothesized the existence of photons, which are particles of light. So what happens is that you have these photons from the sun. Those are particles of light. They hit this solar cell, which is made of silicon. At least the old ones were made of silicon. If the photon has enough energy, if it's a high enough frequency, it'll knock an electron out of the silicon, and then the electron generates an electric current. It gets a kick, and it generates electric current that can be turned into electricity, electric power. That's how solar cells work. But the first solar cell that generated electricity wasn't made until 1954. It's shown on the bottom left here, and I believe it was um, yeah, the people who invented it were Darrell Chapin, Calvin Fuller, and Gerald Pearson of Bell Laboratories. And, we've had these things since the 1950s. We haven't done too much with them yet, which I think is really unfortunate. It's already 2025. We've had solar cells for 71 years. They have gotten cheaper, and I think we should have a lot more of them. I mean, it's a clean, renewable source of energy. How great is that? You know, uh, you know, I've never owned my own house, but when I do finally buy my own house, I'm gonna put solar cells on it. I want to be completely powered by solar energy. So that's solar cells, and now we can store the energy as well. Number 17, radar. This is primarily a military based invention. Pretty remarkable invention, though. I mean, it was the first, radar was the first device that was able to scan objects, tracks where they are, uh, using radio waves. And I guess the first practical radar system wasn't built until 1935. This is shortly before World War II. The guy who invented the first radar system, first practical radar system, was a Scottish engineer named Robert Wilson Watt. He's shown on the bottom right. And the radar unit, the original radar unit he built and demonstrated is shown to his left. And I think you guys all know that radar has been used extensively since World War II. It's pretty remarkable. And it's not. It doesn't just have military applications. It also has practical applications. Just about every airport in the world, I think, has a radio tower that uses radar to track where airplanes are in the sky because that's really important. Air traffic control relies on radar. It's how we can pick up signals from airplanes. It's how we know where they are. The radar, the radio waves, they bounce off of materials, usually metal. They bounce off most airplanes. There is a thing called stealth that was, I think, first built in the 1980s. Now we have certain airplanes that are invisible to radar. But other than that, every airplane in the world can be tracked by radar, which is pretty remarkable. So this was a good invention. And number 16. I think I'm just going to read this one verbatim from what I wrote because I like what I wrote about it. This is the ultra oral contraceptive pill, which was invented in 1960. And I'm just going to read what I wrote here. I think I'm going to have to take off my glasses for this. Um, One of the most revolutionary inventions of modern times, and the one which has had most dramatically affected our sexual behavior, is the oral contraceptive pill, more commonly known simply as the pill, taken daily by women who wish to avoid pregnancy. Although other forms of contraception are used as well, and many had been used for a long time beforehand, the oral contraceptive pill is the easiest to use and one of the most effective as well. The first oral contraceptive pill, known as Enovid, shown on the top right, was first developed and prescribed in 1960. Shortly afterwards, various oral contraceptives were sold over the counter and continue to be today. As shown on the lower right, these pills are typically placed in packs of 28, each one to be taken in turn according to the typical 28-day menstrual cycle of most women. The widespread availability of the pill was in part responsible for the sexual revolution of the 1960s, characterized by a dramatic rise in sexual activity throughout most of the world. So, we can't deny the importance of the pill. I mean, I think it was a pretty great invention. I know people have controversial opinions about the pill. I know there's a lot of religious organizations that are still against it. But I think it was a great invention. I mean, think about it. Now we can have sex with our partners. We don't have to worry about them getting pregnant. And I think that's great for both men and women. And obviously it's transformed as society. It did lead to the sexual revolution. I mean, I guess you could say it led to a lot of unnecessary promiscuity. It might have even led to some STDs like AIDS. We have to be careful about sex. I mean, but the fact that we can do it a lot more easily now and don't have to worry nearly as much about the consequences, I think that's great. But maybe the pill wouldn't have been so effective if it weren't for this next invention. The air conditioner. I mean, I think this is a really great invention. I live in Las Vegas, where it gets up to like 120 degrees in the summer. I mean, without air conditioning here, I don't think I'd survive. I don't think most people in Las Vegas or climates that are hot as this, or even I think anything over 100 degrees, you're not going to survive without an air conditioner. So we need air conditioners, and it's great that we have it. And they've had a long history. The first air conditioner was actually invented as long ago as 1902 by the guy shown on the slide, Willis Carnier Carrier in 1902, and yeah, it was a big bulky machine. The first air conditioners that were used for practical application were used in movie theaters, and I think the first movie theater to have air conditioning was in 1922. And then by the 1930s, people started using them in homes. I think the first household air conditioner was used as early as 1932, but they weren't really, affordable until the 1960s, I'd say. And now, I think starting in the 1970s, just about everybody, at least in a climate that requires it in the developed world, has had air conditioning. And I think that's a really good thing. And I can't even imagine the world now without air conditioning. And they're not just used in houses, and theaters are also used in cars. Cars have had air conditioning. Most commercial cars have had air conditioning since the 1970s. So great invention, I think. Number 14, the laser. This is one I really like. And I know how they work because, I when I was a teenager, I worked at the Exploratorium. It's a hands-on science museum in San Francisco. First of its kind, great museum. And, I had to demonstrate a helium neon laser. They had a half a milliwatt helium neon laser that you could demonstrate. You could show people how it worked. And I learned all about lasers when I was working at the Exploratorium. And I can explain exactly how they work. I think I do a little bit in this slide, but I'm going to give you a full mini lecture about lasers. Laser is an acronym that stands for light amplification by stimulated emission of radiation. And the person who discovered the principle behind the lasers was none other than Albert Einstein. He not only was he famous for relativity, he also came up with a correct explanation of the photoelectric effect, which involves photons. And another thing he discovered about photons was that if you shone a photon, which is a particle of light, on an excited atom that has a transition of the same frequency as the photon that's incident on it, it will stimulate an emission of another photon by that atom. And what's remarkable about that, the second photon that's emitted by the atom has exactly the same frequency, direction, and phase. It's like a clone of the first photon. And you can do this enough times, and this is what lasers do. So a laser is just a tube. It's a tube with a material inside, usually gas. The one I was demonstrating was a helium neon laser. It has helium and neon inside its tube, and it excites a transition in the. I think it's in the spectrum of the neon. There's a particular spectral line. Its frequency is 6,328 angstroms, or 632.8 nanometers. That's its wavelength, rather. And that's in the red part of the spectrum, I guess, sort of red orange. And what happens is, you put a current in this tube, and it starts exciting the atoms. They start emitting photons at this frequency. But then if a photon hits another atom, it does a stimulated emission. But then you have these two mirrors on the end of the laser. One of them is 100% reflective mirror. The other one, where the beam comes out, is like 97% reflected. So now what happens is you get all these stimulated emissions, and the ones that end up going along the length of the tube go back and forth. So now you've got a collated beam of photons, all moving in the same direction, all with the same phase. You have a little tiny hole in the end where the beam comes out. That's your laser beam. And laser beams are amazing. I mean, unlike light from a flashlight, which is, has all the colors of the frequency in all different directions and scatters, a laser beam stays, what's the word, coherent, so that it doesn't spread. It practically spreads nothing. And, it has tons of uses, tons of applications. I show one of them on the bottom of the slide. They're used for entertainment, for one thing. I think probably most of you have been to a laser light show. There's some pretty amazing laser shows using very powerful lasers. You can see the beams. You couldn't even see the beam of the laser I was using when I demonstrated the Exploratorium. All you could see was a dot, on whatever it was hitting. But more powerful beams, you can see them in the air. And there's just tons of uses of lasers, and I named a few of them here. Entertainment's just one of them. There's much more practical uses like surveying. You can determine exactly how far away something is by the time it takes a laser beam to hit it. And we've actually measured how far the moon is within a few centimeters with lasers. And there's also security. I think a lot of home security systems and a lot of building security involves lasers. If you trip a laser beam, it sets off an alarm. Uh, and there's also the military, unfortunately. I don't know how much they've been used in warfare, but I know the military has built some very, very powerful lasers. I mean, I'm talking gigawatts. That's the one that almost made Doc Brown pass out with that word in Back to the Future. But gigawatt is a billion watts. There are billion watt lasers that could, probably destroy entire buildings, which is pretty horrifying, I think. But they're also used for scanning. Supermarkets use them. Or drugstores, when you're scanning items, it scans the barcode using lasers. So they're very, very useful. And the first laser was made in 1960, and it's shown on the top right. It was a ruby laser. So anyway, that's lasers. Number 13. This is probably the most horrifying invention. It's the most important, horrifying on my list, anyway. And I think you guys all know about the atomic bomb, or the atom bomb, or the A bomb. It was invented in 1945. It was the final result of the Manhattan Project, which was the big distributed project performed in the United States at Los Alamos, led by a very famous physicist, Robert Oppenheimer. There was a really excellent movie about him that came out a few years ago called Oppenheimer. He's known as the father of the atomic bomb. Yeah, I think it's kind of unfortunate we have them, but Einstein, Albert Einstein, who was a big pacifist and a great humanitarian, he hated war. It was a big reason he left Germany. Also, when Hitler got to power, he had to because he was Jewish. And what happened, and this is a very unfortunate set of circumstances, but it turned out that nuclear fission, which is the principle behind how the atomic bomb works. This is how you split an atom. You split a uranium atom and a heavy atom, like uranium, by bombarding it with a neutron that causes the atom to split into two fragments, usually barium and xenon. Was it barium and krypton? Uh, and it also releases two neutrons and a lot of energy via equals mc squared. It turns out that the decay products have about 1/10% less mass than the original uranium, and that extra mass, that mass loss gets converted into energy. V equals mc squared. And since c is, that's the speed of light, in metric units, that's about 3 times 10 to the 8th meters per second, 300 million meters per second. That's the speed of light in metric units. You square that, and you get the conversion factor from matter to energy, which is a huge, huge number, 9 times 10 to the 16th. So every kilogram of matter has an equivalent amount of energy, 9 times 10 to the 16th joules. That's about the world power, total world power use in one day. That's how much energy comes from 1 kilogram of ordinary matter. And the first atomic bomb had 30 kilograms of uranium, I believe, or maybe 30 pounds. I forget. But about 1/10% of that matter got converted in energy, was enough to make this huge explosion at Trinity. This is the first test explosion of an atomic bomb, the one that was built at Los Alamos, that they detonated at the Trinity site and watched it from about 10 miles away, safe distance. And then, unfortunately, it was used against Hiroshima and Nagasaki at the end of World War II, killing hundreds of thousands of civilians, which I think was really terrible. I think we just should have demonstrated it. Although I wouldn't have had a problem if we dropped it on Nazi Germany. Uh, and the other thing I want to say about all this, even though Einstein was a pacifist, he actually wrote a letter to President Roosevelt in 1939, urging him to build a bomb. And the reason he wrote him that letter was because it was in 1938 where just the previous year, there was a team led by Otto Hahn in Germany, in Nazi Germany. Hitler got into power in 1933, and Einstein was sure that the Germans were going to build a bomb if we didn't. He wanted to make sure that we got it first. And it turned out that Germany they didn't even really get close to succeeding at building an atomic bomb, it turned out. But we didn't know that. For all we knew, they were going to build their own bomb. But anyway, that's the atomic bomb. And only 2 of them have ever been used in warfare. And I think there's one more thing I have to say about all this before I get off. There's another even more horrible invention, which was invented just shortly after the atomic bomb. That's called the hydrogen bomb, or the H bomb. That was due to Edward Teller, who I think was a pretty horrifying person. I mean, hydrogen bombs use fusion. The atom bomb, the A bomb, uses fission of uranium, but hydrogen bombs use fusion of hydrogen, which converts about 1% of the mass to energy. So about 10 times more mass gets converted to energy. It even uses an atomic bomb to detonate it. Horrible, horrible device. I don't know why Teller ever wanted to build a hydrogen bomb. Oppenheimer, who was the father of the atomic bomb, even told Teller that he thought the hydrogen bomb was evil. But unfortunately, we've got thousands of hydrogen bombs as well as atomic bombs now. And I think it's just fortunate we haven't used them in a war. But, anyway, that's the atomic bomb. Number 12. And here's a peaceful use of nuclear power, the nuclear power plant. The first nuclear power plant was built in the Soviet Union, and I think it first began operating in 1954, shown on the bottom left here. And, we started building our own nuclear power plants shortly after that. I think the first one was built in the United States in 1956. Now we get about 8% of our electricity from nuclear power. France gets about 70% of its energy from nuclear power. And, nuclear power got a very bad name in the 1970s. I think this is really unfortunate because I know this firsthand. I know that statistically, nuclear power is actually one of the safest forms of power production there is. For one thing, it doesn't leave behind any greenhouse gases, so it doesn't contribute to climate change. And also, statistically, the number of fatalities due to nuclear accidents is much, much lower than it is for just about any other form of power production. Especially coal. Coal and oil are much more dangerous, and I think natural gas too, than nuclear power. And we have had some pretty terrible nuclear accidents. Don't get me wrong. Chernobyl was probably the worst of them. I mean, that killed, I think thousands of people, and it left an area the size of Pennsylvania uninhabitable for I think 30 years. It may still be. I don't know. That was in 1986, and there was another terrible one. I can't remember the name, but it was in Japan, and it was triggered by a tsunami, and thousands of people died from that one as well. So I'm not saying that nuclear power is perfect. There are problems with another problem I didn't even mention is the waste. The nuclear waste. But I'll tell you another thing. And I think this is pretty horrible, in my opinion. We could make nuclear power plants much safer and yield more energy at the same time. Ever since the 1970s, I don't know why they did this, but the government made it illegal. The U.S. government made it illegal to reuse nuclear fuel, the nuclear rods. And it turns out that you can get about 10 times as much. You can reuse them up to about 10 times. You can get about 10 times as much nuclear energy by reusing the uranium rods. And we'd easily have enough nuclear power to last us another 100 years if we did that. And we'd also clean up the waste. The waste would be a lot cleaner if we reused it. But we're not doing that. And I think it's really, really a shame that we're not doing that. And that we don't have more of these nuclear power plants. I mean, people, a lot of our fears of nuclear power are really unfounded. Okay, I mean, I just talked about the atomic bomb. And yeah, that is a terrifying invention. There's no question. Nobody wants to be nuked. And nobody wants to die of radiation poisoning either. But another thing that most people don't realize is that it is literally impossible to have a nuclear explosion like Hiroshima, like you would get from an atomic bomb or a hydrogen bomb. It is literally impossible for that to happen at any nuclear power plant. And the reason for that is you need a critical mass. You need a critical mass of uranium to get a nuclear explosion, to have a chain reaction. And nobody's ever done that. at a nuclear power plant. I mean, the uranium is in rods. It's not even pure. It's just, you have uranium mixed with other metals, and it's nowhere near a critical mass in these rods they use to produce the power. And the power is all controlled. It's all, very tightly controlled by robots, I think, that move the rods in and out. So it's very well regulated. And yeah, I'm not saying it's perfect, but I think it's a really good form of energy. And I'd like to see more of it. And I think we're going to need it, actually. I think we're going to need a lot more nuclear power plants before, we completely destroy the environment via climate change from burning fossil fuels. But anyway, that's enough of that. I mean, I guess I'll just say one more thing before I get off this. Another even better invention would be a fusion plant, a fusion power plant. Unfortunately, we haven't built one yet. Nobody's built a working fusion power plant. That would solve a lot of the problems of nuclear power. I mean, this is another form of nuclear power. It's fusion, the same thing that, yeah, works for hydrogen bombs, but with fusion, you're using hydrogen. Again, it's controlled. And since there's so much hydrogen in the world, I mean, the whole ocean is 10% hydrogen because it's water, which is 10% hydrogen and 9%, 90% oxygen by mass. You can use the whole ocean to get hydrogen, as much hydrogen as you want. And this would, like, the amount of power we would get from fusion is staggering. And it's also clean because doesn't involve any greenhouse gases. So, I think we should have a Manhattan Project to develop fusion. But anyway, enough of that. Number 11. Okay, I should have introduced this one first. Number 11, just one word: plastics. That's from The Graduate, in case you don't recognize that line. Yeah, I mean, think about it. Our modern world. There's plastics everywhere. I mean, plastics has just dramatically transformed our society. Now so many things are made of plastic or different types of plastic. Plastics are synthetic organic compounds. They're all based on carbon. And there's so many, since carbon is such a versatile element. It allows, because its valence is 4, it allows for literally, thousands, probably hundreds of thousands, maybe even millions of different types of compounds, and you can manufacture them to with the properties you want. And this has been done since 1907. The first person who invented a practical form of plastic was, his name was Bakeland. Leo Bakeland, and he patented it, and he even used the word Bakelite for his plastic. And there's a picture of the first telephone that was made from plastic, from Bakelite on top. And since we've had many, many other forms of plastics, uh, I mean, just all over the place. And they're great. I mean, we can manufacture plastics to have pretty much any of the properties we want. And they can be very, very strong. They can be very, very stretchy. They can hold objects. You can shape them however you want, like Tupperware containers. CDs and DVDs are made of plastic, you name it. Plastic's all over the place. But I think the problem with plastics is that they're a terrible pollutant. And now the ocean is filled with just tons and tons of plastic. And it's killed most of the marine life in the ocean already. And I just learned this maybe a month ago or so. I heard Bill Maher say this. We're killing the ocean. We've already killed a lot of the marine life in the ocean. But this is affecting us as well because the ocean is a big source of oxygen in the Earth's atmosphere. And he even said, I don't, I'd have to see statistics to back this up, but he said that we're in danger of depleting the oxygen in the Earth's atmosphere because of all the plastic in the ocean. And that's really scary to me. I mean, I just hope we don't suffocate because of depleted oxygen in our atmosphere due to all the plastic in the ocean. And we have to do what we can, I suppose, to try to get rid of all that plastic, and maybe come up with environmentally safer materials, or at least dispose of it properly. We can't dump all of our plastic into the ocean because it's going to kill us if we do that. Anyway, that's plastics. Um, and Number 10. Now we're getting some really big ones. Television. I mean, we can't deny the importance of television. I mean, I think now just about everybody in the world has a TV set. Um, Television, it's older than you might think. The first TV transmission was performed in 1926. The guy who did it was a guy named Scottish electrical engineer John Logie Baird. He performed the first TV transmission. He had all the equipment in his laboratory, a TV camera and a TV receiver, and he only did the broadcast across the laboratory. But then the following year, 1927, there was the first long distance broadcast. There was a TV signal broadcast all the way from London to Glasgow. And, in the United States at least, there were three big broadcast networks, NBC, ABC, and CBS. I'm sure you guys have all heard of them. They all, I think, started broadcasting, if I'm not mistaken, in 1948. Then he started getting the first TV shows on the air, and that started a whole generation of couch potatoes, basically. A lot of people started just watching TV, getting addicted to them. There's a lot of crap on TV. Let me tell you, I think most of the broadcasts we've had on TV, in my opinion, have been crap. I mean, it's a cheap form of entertainment, not anywhere nearly as good as movies. I don't know. As a kid, I watched a lot of TV, like all kids do, but I don't like watching TV. I don't even have any TV networks on my. I have one of the HD TVs shown on the right. I have a 60-inch HD TV. These are really remarkable. I mean, TV in itself was a really remarkable invention, but there were also, a lot of improvements like there are in most technologies. I mean, the first TVs ever made were these kind of, they used CRTs, cathode ray tubes, and they were all black and white at first, and most of them were pretty small. The screens got bigger, and then we got color TV by the 1960s, and then we got big screen TVs. The first big screen TV I ever saw was in the late 1970s, I think. You had ones you could project on the wall, and then you got HD TVs. I think I don't know exactly when those came out, maybe 90s or early 2000s. But now you got TVs with much higher resolution than the old ones. The old ones had just 527 lines that would scan across your screen. Now I think they use thousands of lines, and it's almost like you're there when you see a TV image now. So there's no question TV technology has evolved tremendously, but there's still a lot of shit on TV. Pretty amazing. I mean, now we have thousands, literally thousands of cable channels to choose from. And still, most of it is crap, in my opinion. And we could have used TV for a lot better things. We could have used it a lot more for education or for, I don't know. But I'm just not a big fan of TV. I mean, an amazing invention, but not used very well in our society, in my opinion. Anyway, number 9. Now we're getting some good ones. This is one I do like. The personal computer, or the PC. And, PCs, it's kind of funny. I mean, computers have been around, at least electronic computers have been around since the 1940s. I'll get to that later. But I mean, all the early computers, they were these big, huge mainframes. And I think everybody thought for a really long time that was how computers were going to be. We were just going to have big mainframe computers that weren't going to be owned by individuals. They were going to be sitting in some government lab or some big company. and we'd all be connected to them, via monitors. That's what everybody thought until the personal computer came out in the 1970s. And the first kind of commercially available PC was the Altair 8800, shown on the far left. I don't think they sold very many of these things. I don't think it even had a monitor, but it was the first PC. And then, PCs have had a long history. I think the first really popular PC was the Apple. I remember the first Apple that came out, the Apple II. That was 1977. That one did have a monitor. There were a lot of other ones that came out shortly after, the Commodore 64. I saw some of these things right when they came out. I thought they were fantastic, and I used to play games on them. I used to love them. I was hooked on them, And I had my own PC in the early '80s. I think 1984 when I got my first PC. I got the IBM, basically the second computer on this picture. I got an IBM PC. I don't know if it was the 5150, but it looked almost exactly like this. It was a DOS based, and these were very hard for most people to use. They didn't really catch on yet. The first one that really caught on was the Macintosh, the third one on this slide. And the reason it did was because it was much easier to use. It had a graphics user interface. It was the first computer with a GUI, graphics user interface, and it used a mouse, and you could draw with it. I think Steve Jobs. He was the original CEO of Apple. He was a genius. I mean, actually, he kind of stole this technology from Xerox PARC. Xerox PARC in 1971. This was Xerox. They came up with what they called the paperless office. But they had the wrong vision, unfortunately. This was 1971. They had a computer called an Alto, which was basically the same as the Macintosh. It had a longer screen, but it wasn't that, Xerox didn't want to make this available to individuals. This was their mistake. They imagined this would be an office tool. It'd just eliminate the need for paper. But they had all the components basically of the Macintosh. They had the GUI, they had the drawing tool, they had the cursor, and Steve Jobs, he went to Xerox PARC to visit them. He took notes on all this stuff, and he made his own PC with an operating system that was basically a copy of what Xerox PARC had already done. I mean, in all fairness to him, he wrote his own software to do all this. And he did develop the Macintosh computer. And I do like Steve Jobs. I mean, he was pretty ruthless, like most CEOs of large companies, most billionaires. But I think he invented a really amazing product. As a matter of fact, I think Bill Gates and Steve Jobs, I think they're kind of the modern equivalent of, I'd say, Thomas Edison and Henry Ford. I mean, yeah, we super rich industrialists who made, nowadays billions based on their invention and how they marketed on them. But I think we owe PCs to a very big extent to those two guys, Bill Gates and Steve Jobs. And also I like Bill Gates because he's done a lot of amazing philanthropy in Africa. He's helped a lot of starving people in Africa, which I think is great. And I like Steve Jobs. I mean, he's dead now, unfortunately, but there've been several good movies about him. I mean, he came up with an amazing product. And I salute him for that. And the last picture on this slide, finally we got laptops. That's kind of the latest development of PCs. And the one shown here, I think, is it's the Apple PowerBook, which came out in 1991. So that's PCs. I still really like PCs. I think nowadays people don't use them all that much anymore. Maybe they never really did. Nowadays everybody's using smartphones and other smart devices, but PCs never really caught on that much. Probably partly because most people don't know how to program. I know how to program computers. That was the only way I was ever able to use my IBM, by the way. They didn't even have software for it back in 1984. You had to learn how to program. That was the only way you could use an IBM PC in 1984. But I already knew BASIC. and you only had to know BASIC to program an IBM. And actually wrote some pretty cool programs for my IBM. I even did some computer graphics simulations. It was very primitive graphics. It was text-based graphics, but I wrote some pretty cool programs back in the 80s that used text graphics to do some pretty cool stuff, including some games I came up with on my own. So anyway, that's PCs. Invention I really like. Number 8. And PCs would not have been possible without this invention here, the transistor. I mean, I think the transistor was a really, really revolutionary invention. I mean, it took the place of vacuum tubes. So the problem here's what the problem was. There's certain type of circuits that require current to flow in just one direction, or to be monitored by another current. And that's exactly what transistors do. Vacuum tubes can do that too, but vacuum tubes are very big. They're basically light bulbs. They're the size of your fist. And what a transistor did, it did the same thing using semiconductors. Semiconductors are some pretty amazing materials that they can act both as conductors or insulators depending on how they're manufactured. And the way transistors work is they have this thing called a PNP or an NPN junction. There's two different types of semiconductors. There's P-type and N-type. P-type have an excess of what are called holes, which are places where electrons are missing, and N-types have an excess of electrons. So you can make a one-way current across a PN or an NP junction, and a transistor has a PNP or NPN. You have two junctions, and that will give rise to a regulated current in one direction that's controlled by two inputs, and that's what's used in computer circuits. So that's how modern computers work. And the first electronic computer that was ever built, ENIAC, that used vacuum tubes. It was a huge computer, size of a big room. But now, it's because of transistors, we can make them smaller and smaller. There's practically no limit how small. There is a limit to how small you can make them. You obviously can't make them atomic size, but you can get pretty close. And nowadays I think the smallest transistors, they're like, I think just a few nanometers. Almost as small as atoms, as small as molecules anyway. Small as we can make them without having to worry about quantum effects due to the uncertainty principle. We've basically reached the limit of Moore's law. There was a thing called Moore's law. I think it was developed by a guy named Moore, which basically just says that it's an empirical law that said, I think, from the 1950s until about the end of the 20 teens, whatever you call that, around 2019 or 2020, computer speed and memory was increasing it was doubling every 18 to 24 months, which means that now computers are about 1 billion times faster and more powerful than the first computers ever built. So they've gotten faster and faster and more powerful. But now we've kind of reached the limit of what classical computers can do because we can't make the components any smaller anymore. But anyway, that's all due to transistors. So a really, really great invention. Number 7. Okay, now the next 4 inventions I think all relate to aircraft basically. So the jet engine it was developed. I don't know any other applications besides an aircraft, but the first jet engine was built in 1930, and it was used so it's shown on the bottom left. It was used in the first aircraft to use a jet engine in 1939. And this was the British aircraft, what's it called? The Gloucester E-28/39. It wasn't the first jet, strangely enough. The first jet was German. It was also 1939. But as far as I know, I don't think any jet aircraft were used in World War II. They were still kind of in their infancy. But we can't deny the importance of jets today. I mean, now we have now just about every airplane that flies is a commercial jet. And I think jets started, the first commercial jet was used, I think, in 1952, was BOAC, which is British. I think it's now called British Airways, British airline. They did the first commercial jet flight, and now just about all commercial flights are done by jets. And there's a lot of advantages, obviously, jet engine aircraft versus propeller engines. For one thing, propellers, planes can't go very fast. I used to fly. I took flying lessons aboard a Piper Cherokee that was built in 1969. And it was 184 power, and it could only go up to about 130 miles an hour. Um, and most propeller planes can't go much faster than that. I think the fastest propeller planes can go maybe about 200 miles an hour. But jet planes can go faster than the speed of sound. As a matter of fact, the fastest jet planes in the world can go about Mach 3, about 3 times the speed of sound, about 2,000 miles an hour. Of course, you have to break the sound barrier first to do that, and that's why we don't have any commercial, except for the Concorde. I mean, the problem with commercial supersonic jets is that they're very, very noisy because they break the speed of sound, which causes a big sonic boom. You don't want to be flying supersonic aircraft over populated areas because it makes a lot of noise. It can even destroy glass, so you don't want to do that. I have heard that I think it's Boeing that's working on quiet jets. Well, that'd be great if we have, I mean, quiet supersonic jets. But for now, at least, we're stuck with subsonic jets. But, you can still get pretty fast. I mean, speed of sound in air is about 750 miles an hour. But, I mean, the jets that can go about 650, at least 600. I think it's somewhere around 600 to 650 miles an hour. That's how fast most subsonic jets fly these days. And that's fast enough to fly you across the country in you know, in less than 5 hours. And, so jets are great. And anyway, number six, the artificial satellite. I think this was another really, really amazing invention and a really great one. And I think we all know about Sputnik, the world's first artificial satellite that was built by the Soviet Union, built and launched by the Soviet Union, October 4th, 1957. This is the thing that started the whole space race. And it really caused quite a stir. I mean, it was visible all over the world. First of all, you could even see it in the sky if you were looking in the right place. And also, it had a radio signal. It was just a beep, a continuous beep, not a very sophisticated single, but you could track it with an ordinary radio. And a lot of people did this. And people saw it all over the world and they were wondering, what the hell is this thing? And they soon realized that the Soviet Union had launched the world's first artificial satellite. And I mean, in all fairness, the United States was trying to get into space, before Sputnik. But the way they were doing it was very different from the way they ended up doing it after Sputnik. See, Sputnik was a satellite that was launched from a rocket, and we weren't trying to launch people into space with rockets. We were trying to build faster and faster planes. We already had a thing called the X-15 rocket plane, which went, I think, like 4,000 miles an hour and got up to about 20 miles altitude, which isn't quite into outer space. I mean, airplanes can't fly in outer space. And the reason they can't is because they require oxygen from the atmosphere. And there's no oxygen in space, there's no air in space. Uh, but we were trying to get into space in a different way than we ended up doing it. We ended up launching rockets ourselves. And that's how we eventually got to the moon. I mean, we had three, manned space programs, during the 1960s. First, we had Mercury. That was the first one that sent the first astronauts into space. They just orbited the Earth. The first couple didn't even orbit; they just went on suborbital flights. But the last four that went into space orbited the Earth, and that was Mercury. I think that ended in 1963. Then we had Gemini, which were the first missions that involved, two people in a space capsule, and they practiced all the stuff we needed to do to go to the moon. We had to practice rendezvous in space. That was kind of the purpose of the Gemini. Also spacewalks. Uh, but then we had the Apollo program, which was the one that got us to the moon. Apollo 11, it was launched July 16th, 1969. We landed on the moon 4 days later, July 20th. And I think you guys all know that Neil Armstrong was the first person to walk on the moon. And there's a picture of him on the bottom right. Pretty amazing that we went to the moon. But almost as amazing and unfortunate to me as we haven't been back to the moon. Nobody has been back to the moon since 1972, over 50 years. I mean, I think this was a tragedy. I mean, I used to be really, really excited about space travel when I was a kid. And I remember watching Neil Armstrong walk on the moon. I watched the moon landing. And I watched all the Apollo missions on TV, all the way up to Apollo 17, the last one, 1972. I even watched Skylab, a little bit of Skylab. I missed the Apollo Soyuz link up. And I watched the space shuttle. I watched the first space shuttle launch. We had a couple of tragedies with the space shuttle. I think you guys all know about the Challenger disaster in 1981 that killed all 7 astronauts aboard, including this school teacher, which was very, very unfortunate. But I was really excited about the space shuttle. I actually wanted to ride it myself. I still want to go to space before I die. It's a dream of mine. I've always wanted to go into outer space. And I just hope I can orbit the Earth at least once before I die. That's a big dream of mine. I want to go to outer space. You know, uh, Maybe the reason I put the artificial satellite only on number 6 is I really haven't done much in outer space, at least manned space voyages since the 1970s, which I think is really unfortunate. And even Obama canceled the manned space program. We can't even launch space shuttles. The only way we can get to space now is to get a ride from a billionaire, which I think is really terrible. But anyway, that's artificial satellites. Number 5, the liquid fuel rocket. I mean, this was the invention that was able to get us into space in the first place. The first liquid fuel rocket was built and launched by this engineer Robert H. Goddard. He's shown on the right side of this picture on the right, and that's the first rocket he launched. And the first rocket didn't go very high. It only went up to 41 feet, and the flight was only 2.5 seconds. But it led to bigger and bigger rockets. There were a lot of rockets built in the 1930s, 40s, and finally by the 1950s, we launched the first satellite. That was the Explorer 1 in 1958. Of course, the Soviets built their own rockets to get Sputnik up. And a big rock, I didn't talk about this in this slide, but a big engineer who designed a lot of the big rockets, including the Saturn V, which took us to the moon, was a former Nazi named Werner von Braun. And I have very mixed feelings about Werner von Braun. I mean, he was responsible for the deaths of tens of thousands of civilians during World War II because he built the V2 rocket, which was used against London. There were bombings of London, and he used rockets to kill people, civilians, during World War II with his rocket. And after World War II, we captured him. We won the war, which was really good. But we captured von Braun and a lot of other, former Nazis and used them for NASA and our space program. Von Braun, he was the brainchild behind all the rocketry that we did, all the missions to the moon, all the missions in space. We owe a lot of that to von Braun. So I don't know what my opinions are about von Braun. I mean, he was a Nazi and he was responsible for deaths of tens of thousands of people, but he was also responsible to get us to the moon. So I don't know if his overall karma was good or bad. Maybe you guys can tell me. But anyway, that was the liquid fuel rocket. Really, really great invention. Number four, the last of my aviation inventions, the airplane. I don't think any of us can deny the importance of the airplane. I mean, God, first heavier than air flying machine. We did have balloons and zeppelins before airplanes, but those were lighter than air. But the airplane was the first heavier than air aircraft. The first person I know of who imagined flying machines was Leonardo da Vinci. This was back in the um, late 15th century, I believe, maybe early 16th. 400 years before the Wright brothers. They were the guys who built the first airplane, shown on the bottom left. And that was the airplane they built, the Wright Flyer. That was the first airplane that ever flew, December 17th, 1903. The first man heavier than air flight. And their flight was very short. The first flight, I think, only lasted 12 seconds, only went 120 feet. And the power of the engine on this thing was only 12 horsepower. But of course, they demonstrated the principle. The principle, by the way, behind heavier than air flight is Bernoulli's principle. This was discovered by a very famous physicist and mathematician. As a matter of fact, one of a big famous family of mathematicians and physicists named as the Bernoullis. There were about, uh, I think, 10 of them, but all did important work in math and physics. And it was Daniel Bernoulli who came up with the Bernoulli principle, which is the principle of lift. It's the same principle responsible for baseball's curving, by the way. What happens is it's the shape of the wing that is responsible for. It's what gives planes their lift. The fact that it's curved on top and straight on the bottom. That means that the speed of the air going on the top of the wing is faster than the speed below because it has to, go the same it has to go from A to B with a larger distance. That means it has to go faster. And Bernoulli's principle says that the faster air moves, the lower its pressure. So that creates a pressure difference. It gives the wings their lift that lifts the airplane off the air. That's how airplanes work. Anyway, but we can't deny the importance of airplanes, and just I think it were amazing invention. Yeah, it was a dream of man for pretty much I think our whole history. We've always wanted to fly, and now we can thanks to airplanes. Number three. Okay, now the last three inventions I may as well tell you now. They all relate to computer technology, and I think the latest invention related to that is the smartphone, which I put at number three. Maybe some of you thought it would be number one. I don't know. I mean, now, most of us have smartphones, at least in the developed world. Just about everybody carries a smartphone, and it seems like, for most people, they're kind of indispensable. I know there's some people that can't even get away from their phone for more than a few minutes. I mean, not only do we use them to talk on the phone, that's why they're called phones, but now we have all these apps you can download on smartphones. They're basically, and the reason they're called smartphones, they're one of a class of smart devices. They're devices that are hooked up to the internet. I'll get to that one later, but they get information from the internet or the World Wide Web, if you like. And the so you not only can you talk on the phone using cellular, you used to have cellular cell phones, smartphones. I think the first smartphones basically was cell phones, and the first smartphone is shown on the top right, by the way. That was a IBM Simon personal communicator, SBC. This came out in 1992. Apple just recently came out with their latest iPhone, the iPhone 16. I just bought one. And so we all have smartphones and they're great. And they can just do so many things. I mean, the apps do, I don't even use all that many apps on my smartphone. Obviously I use it for talking on the phone. I guess I'm kind of old fashioned this way. I still like to talk on the telephone versus texting. I really don't enjoy texting. I do text though because everybody does. And also, there are advantages of texting. You can send photos and you can take photos. I mean, that's another amazing app. on these smartphones. I mean, digital photography. You know, when I was a kid, I used to have a film photo, camera. I mean, people were taking photos with film. I'd say most people were doing that probably until the 1990s when we started coming up with digital cameras. And now we have them on our phones. And I think they take even better pictures than the old film cameras I used to use. You don't have to develop them. You just take them and right away they get stored on your phone. It's digital information. And tons and tons of other amazing maps. I talked about GPS already. I use Google Maps on my phone too, to navigate. And of course, there's a lot of games you can download. There's a lot of other shit you can download on your smartphone. Probably the most widely used smart device these days. So we can't deny the importance of smartphones. Number two, the internet. So the smartphone wouldn't have been possible without the internet, obviously. And the internet is really, really amazing, I think. And I think it's one of the marks of this century, this millennium so far. I mean, practically nobody was using the internet until the 21st century. I was. I mean, I started using it in the 1990s. It wasn't fully developed until, well, I mean, 1973, I guess, is when the government, it was developed by the government. And it was actually used like most things the government did. It had military applications. They wanted to develop a distributed computer network to keep track of information. And at that time, it was mostly military information they were interested in. But it was a big collaboration and also involved some universities. There was information that I guess some of these universities wanted to have on the internet. Mostly pertaining to I guess computer data, science documents, physics documents, whatever. But I didn't start using the internet. I think the first internet server I used was called CompuServe. This was back in 1992. I got it in the mail and I downloaded it onto my computer, and it was cool. You couldn't do all that much with CompuServe, but then shortly after that, America Online came out. I don't remember the exact year I started using AOL. I think it was shortly after it came out, around 1994 or 1995. But I loved AOL. I used it for about 10 years. I went into a lot of chat rooms. I would use it about maybe 5 or 6 hours a day. I was pretty hooked on AOL for a long time. I don't use it anymore. I mean, now it's obviously outdated. Uh, but that was the internet. And then we had the World Wide Web, which was kind of the commercial part of the internet. And I've had personal computers ever since the 80s. I told you about the first IBM PC I owned. I've had PCs all my life ever since the 80s, and I was using the World Wide Web. I guess starting in the 90s, late 90s, and that's really just the internet. And now I think the internet's indispensable. We use it all the time, and I'm using it right now, to make this video, and our lives just wouldn't be the same without the internet. So pretty amazing invention. I think I've said all I have to say pretty much about the internet. I think it mainly just speaks for itself. Anyway, that's number two. So what's number one? Well, number one is the invention that really is responsible for a lot of these other inventions on my list, at least the last three, and several others, I think, as well. And that's the electronic computer. I mean, I just think, I think the electronic computer is one of the greatest inventions of all time, not just modern times. And the first electronic computer was called ENIAC. There's a picture of it shown on the top right. I think I mentioned it already. It was the size of a whole big room. And, I already talked a little bit about ENIAC. Maybe I don't have to say any more about it, other than the fact that I think it was only about a kilobyte. I mean, nowadays a smart watch is a lot more powerful. And even an iron, I think, has more computing power than ENIAC. But it was the world's first computer, and there were some pretty amazing calculations done with it. I know, for instance, that pi was calculated at 2,000 decimal places using ENIAC. And I think it was mostly used by the military. I think it was used by the army. I don't know what other kind of calculations they did with ENIAC, but I know about that one. And now we have these big supercomputers. The thing on the bottom right, this was a supercomputer built by, um, I think it was IBM. Yeah, IBM Blue Gene P supercomputer. This was built in 2007. I actually used a supercomputer once. You have to rent time on a supercomputer. But I used a supercomputer back in the late 1980s. Maybe it was the 90s. I can't remember. But I think I used one of the world's first supercomputers. I used it to calculate all the prime numbers up to 1 million. I wasn't supposed to do that. I think they banned my account because they knew I was using it for fun. But anyway, computers are amazing. And I think I should mention one more thing I didn't mention on this slide. The guy who's usually called the father of the computer was a 19th century engineer named Charles Babbage. He tried to build the world's first computer, but it wasn't an electronic computer. It was a steam powered computer, believe it or not. But he lived too early. I mean, there were two major inventions that were not yet made that he would have needed in order to succeed. He actually built something called an analytic engine. That he did succeed in building. That was a calculator, basically. It wasn't a computer. But you could do calculations with this analytic engine, which was another steam-powered engine. Oh no, I'm sorry, I got it backwards. The difference engine. That was a calculator, and it used differences to calculate, elements of sequences. It was useful, but it wasn't a computer. The analytic engine would have been the world's first computer. Actually, I think it was completed in 1910. So if you like, that was the world's first computer, but it wasn't an electronic computer, and I don't think it was really practical. But the first electronic computer, like I mentioned, was ENIAC, and then of course computer technology just took off after that. They got more and more powerful according to Moore's law. And I think I should say one more thing about computers before I'm done here. The guy who came up with the principle behind computation was a very, very famous mathematician, very tragic figure too, Alan Turing. There was a movie about him called The Imitation Game. He was an amazing guy, and he came up with the whole. He came up with this theoretical machine called a Turing machine, which is basically it's a tape. Now they're real Turing machines. They're not practical, but it's really just a device that reads a tape. It has an input, which is this tape, and it has all these states. And according to what state it's in and what symbol it's reading on the tape, it can print. It can erase a symbol and print a new symbol and move to the left or the right. That's all it does. Pretty simple device. But what Turing's genius was, what he realized that with this very, very simple device, you could, in principle, make any classical computation in the world. And I'm saying classical, there's also a thing called quantum computation. He didn't know anything about that. That wasn't developed until the 1980s. But at least a classical computer that's deterministic, that has an input and an output and does a bunch of computations and stores things in memory. All that can be done by a Turing machine. Every classical computer in the world is basically a Turing machine. It works by the same principle. And even Babbage's machine, it turns out, even his analytic engine, it turns out that that's also a Turing machine. It's what's called Turing complete. I mean, there have been some computers built that weren't Turing complete. I don't know if you could really call them computers, but almost every classical computer that's ever been built has been Turing complete, meaning that it can compute anything that could, in principle, be computed classically, which is basically any kind of computation you can think of. So anyway, that's electronic computers, and that's my number one invention of modern times. And that completes my entire series on the history of inventions through different periods of history. Today was modern times. And thank you for watching. Keep thinking, and I'll see you guys next time. Bye.